on this e-learning platform of Apex Institute of Physics. Here is the general information about the instructor and the course. This is the second video on electric field. So let's go ahead. Electric field due to a stationary point charge. So because of a point charge, what the field is, we are going to talk about here. So let's say this is plus q charge. Its size is ignorable, and at a distance r from here at point P, if we placed a positive test charge q naught here, then you will find on this positive charge force will be acting in this direction. Since charge is positive, the direction of force is same as the direction of field, hence the field will also be in the direction of force, that means away, radially away. Similarly, if we have a minus q point charge and we assume a unit positive test charge q naught here, then on this positive test charge electrostatic force will be acting towards the minus charge, because this is going to be attractive, and we know the direction of force decides the direction of field if the test charge is positive. This is how we can calculate the direction of field at any point P. Nutshell, we can say because of a positive charge the direction of field is going to be radially outward. For a negative charge, the direction at any point of electric field is going to be towards that charge or radially inwards. After learning the direction of electric field, we can find the magnitude of electric field. As per this, magnitude of electric field is the force divided by charge. Now if we write the force, Coulombic force, we know it's going to be K Q naught divided by Q naught, and then R square. So the field formula turn up as E is equal to simply K Q upon R square. So that's the magnitude of electrostatic field, which is also written there. K can be written as 1 upon 4 pi epsilon naught Q upon R square. This is being considered in air or vacuum. Now since E is a vector field, so we have talked about the direction and magnitude separately. We can combine the direction and magnitude together to write in the form of vector form. So it's going to be, in vector form, it's going to be E is equal to the magnitude and the direction, right? So direction of the field is going to be in the R direction. So if the charge is positive, so R cap will be leading this E direction, and if the charge is negative, so E direction will be opposite to R cap. So this becomes the formula for electrostatic field in vector form. This further can be rewritten in different fashion, or in this manner. E as a vector is equal to, I am writing this K, which is for constant, Q divided by R square, and then we can keep it as R cap. Here we have written R cube because R vector has been used. So this is representing the magnitude, and that is representing the direction. Here Q has to be placed with the sign. If it is positive, then has to be written as a positive, negative, then has to be written as a negative. Principle of superposition, as we have earlier talked about, it says vector sum is the total electric field. So at any point, if we are looking for the total field, it is going to be because of each individual charges field sum. So we will be summing all the fields. So that's called principle of superposition. There is an example of using superposition of electric fields. So it says 3-point charges have been placed on equilateral triangles vertex. Each has a charge q value. We need to find force on, let's say, on this charge q because of rest of the two. So we can say the net force on this charge is going to be equal to q into net field. Now for getting the net field, we can write, if this is E naught and E naught, because of these two charges, we can say their resultant is going to be twice E naught cos 30 degree. And we can find what this cos 30 degree is. First of all, we need to find what the E naught is going to be. So as per the formula, it goes KQ upon R square, which is A square. So the net force is going to be equal to 2 small q into E naught, which is going to be KQ upon A square into cos 30. Cos 30 is root 3 by 2. try this question based on that.